BTS attributes. Resolution. Resolution is a drop-down menu with the following list: reported, assigned, fix in progress, fixed, fix is verified, verification failed, cannot reproduce, duplicate, not a bug, third-party bug, no longer applicable. Resolution is one of the most important BTS attributes. If status is about global things like was born, died, and got reincarnated, resolution provides details like graduated from college, got married, bought a condo, etc. Resolution describes the stages of a bug's life. What drives a bug from one life stage to another? Certain activities geared towards bug resolving. Where can we find information about those certain activities and the associations between them and the concrete values for resolution? In the bug tracking procedure. Let's learn about each resolution. By the way, because the majority of bugs are found in the software, not in the specs or other documentation, we'll be talking about situations where the person responsible for the bug fix is the programmer. In our course, each resolution is illustrated by a bug filed into the bug tracking system of Test Portal. You can see those bugs here: Test Portal, Bug Tracking, Bug Vault. Resolution reported. This resolution must be chosen when the person who files a bug doesn't know who will be fixing the bug. This is the situation when a tester assigns a bug to himself. By the way, in case of sophisticated BTS software, we can program our bug tracking procedure into the BTS workflow. For example, depending on the situation, the required resolution value would automatically be selected. For this course, we assume that the people who use the BTS voluntarily follow the BTP. See Bug Vault, bug number 2. Resolution assigned. This resolution means that the programmer in assigned to should investigate the bug. Example 1. The person who files a bug knows who is going to fix it, so that person selects name of the programmer from assigned to and selects the assigned for resolution. See Bug Vault, bug number 3. Please note that this bug was invented to illustrate the point. ShareLane application doesn't have this bug. Example 2. The person filed a bug with reported status but changed reported to assigned and put programmer's alias into assigned to once he found out who was going to fix the bug. See Bug Vault, bug number 4. Pay attention to change history. Resolution fix in progress. The programmer selects this resolution as soon as he starts working on the bug fix. See Bug Vault, bug number 5. Pay attention to change history. Resolution fixed. The programmer selects this resolution as soon as he has checked the bug fix into the CVS. Along with that, the programmer must select the same alias as in verifier from the drop-down menu assigned to. See Bug Vault, bug number 6. Pay attention to change history. By the way, testers should remember that it takes time before the build script picks up the CVS content and populates it onto a particular environment. So, if a programmer changed the resolution to fixed at 8 a.m. and the next build starts at 9 a.m. and takes 15 minutes to complete, then the bug fix will be available on the target environment no earlier than 9:15 a.m. The moral of the story: before you start regressing the bug, make sure that the build with the bug fix has already been pushed to the target environment and that the build was successful. In other words, check out 2 things before you begin bug fix verification. Build status. See examples at Test Portal, Release Engineering, Build status. Application version on the target environment. You can see if you view the HTML source of any web page on ShareLane.com. Resolution fix is verified. Remember that bug regression consists of 2 parts. Part 1, verification that the bug was really fixed. Part 2, checking if the bug fix hasn't broken some other parts of software. First of all, we just try to reproduce the bug following the instructions in the description. If the bug is not reproducible, then it was really fixed. If the bug is reproducible, then it wasn't fixed, so we send it back to the developer with the resolution verification failed, and we do not execute Part 2 of the bug fix verification. If the bug is not reproducible, we move to Part 2. This is where it gets interesting. In the case of more or less complex software, it's sometimes extremely hard, even for a programmer, to confidently predict how a certain change to a certain piece of code will affect other parts of the software. So, the only way to do comprehensive regression testing is to perform 100% coverage of all possible scenarios, what's usually impossible. The standard way to execute Part 2 is to perform a basic end-to-end test of the feature that contained the bug. In special cases, for example in case of emergency bug fix, you can A. Ask the developer who fixed the bug what could have gotten messed up as a result of the bug fix and what he recommends that you check out in particular. B. Next, follow his instructions. C. Then perform a basic end-to-end test of the feature that contained the bug. Please note that you can change the resolution from fixed to fix is verified, and close the bug, change its status to closed as soon as Part 1 is finished and you have verified that the bug was really fixed. Why bother about Part 2? We need Part 2 simply as a safety measure. Of course, in the case of Part 2, we're not talking about serious testing. We just do a quick check that usually takes several minutes. See Bug Vault, bug number 7. Pay attention to change history. Resolution: verification failed. The verifier changes the resolution to verification failed and assigned 2 to the alias of the responsible developer if the bug is reproducible. That's if Part 1 of the bug fix verification failed. See Bug Vault, bug number 8. Pay attention to change history. Resolution cannot reproduce. This unpleasant situation occurs if the developer tries to reproduce the bug assigned to him or her and cannot do it. The bug is usually not reproducible for one of 3 reasons. 1. The tester didn't provide a comprehensive description. 2. The tester's environment and the developer's environment are different. 3. There is no bug. Let's look at these reasons one by one. 1. The tester didn't provide a comprehensive description. One of the main concepts about the bugs is the idea that if a bug exists, then it is reproducible. Never file a bug until you reproduce it at least once after you discovered it. Read the following brain positioning and remember it for the rest of your testing career. Brain positioning. Sometimes you can get really excited once you find a bug, especially a fat P1, and you can be tempted to run to the developer right away to share your finding. Don't do this. Whatever the problem is, 1. Try to reproduce it. 2. Try to narrow it down. In other words, try to isolate the problem. For example, let's assume that after you clicked the Make Payment button using Google Chrome on Windows 8, you got a 500 internal server error. What you should do next is this. 1. Try to reproduce it again and write down the exact parameters: book title, price, quantity, credit card info, type, number, CVV2, expiration date. 2. Play with those parameters. For example, try to reproduce the bug using a different credit card. 3. Try to use a different browser OS combo. For example, try Firefox under Windows 8 or Google Chrome under Mac OS. If a feature is on production and you found a bug in the test environment, try to reproduce the bug on production. After your 4-step investigation is done, file a bug report right away or go talk to the developer and file the bug right after that. Again, if a bug exists, then it's reproducible. Each bug is a result of a certain scenario, which is 1. Actions, 2. Data, 3. Conditions. Usually, people are more focused on providing info about actions and data rather than about conditions. Try to avoid that pitfall. In many cases, it's the condition that makes all the difference. In some cases, a condition can be very unusual or hard to grasp. But if you pay attention, you'll find that condition. Please read the story below to better understand my point. 4 scientists and 1 flask. Once upon a time, there was a pharmaceutical laboratory where 4 scientists worked to find cures for illnesses. Scientist Leo N invented a unique chemical substance that could serve as the basis of a new powerful medicine. The problem was that 3 other guys could not produce the substance even if they methodically followed Leo's every step. Leo was happy to share all the information he possessed about the process, but the others had no luck. It seemed like Leo had some unexplainable ability. One evening, those 4 scientists with their PhDs in chemistry got together and decided that they were going to believe in miracles, but only after one last thing. During the preparation of the substance, Leo's each and every action must be captured on video and analyzed afterwards. Following the plan after the video was ready, the 4 colleagues got together and made a thorough analysis of each and every one of Leo's actions. After several hours of analysis and conducting tests, they found out what was really happening. In the middle of the preparations, whoever was preparing the substance had to walk for 1 minute between the 2 laboratories, which were situated in different buildings. It was wintertime, by the way. Leo was a smoker, so before going outside, he would put the flask under his coat to free his hands for a cigarette and matches. Therefore, the substance in the flask wasn't exposed to the cold like it was with the 3 other scientists who didn't smoke and who simply ran between the buildings with the flask in their hands. So, the magical condition that made all the difference was, don't expose the flask to the cold. The moral of the story here is that, in some cases, even a little hard-to-notice nuance makes all the difference. Let's get back to our testing. In many cases, a bug is not reproducible, not because the tester didn't know the scenario's conditions, but because he just didn't write a comprehensive description. Brain positioning. Please remember that even if you get excited about finding some buggy area and you want to continue hunting for bugs instead of filing bugs, it's your direct responsibility to file bugs. Make sure that others can understand your bugs and be able to reproduce them. It's really bad when a developer must put off his coding, spend time trying to reproduce a bug, and is not able to do it because the tester forgot to include the little detail right in the middle of steps to reproduce. You must avoid situations like that. Do your best to avoid merchandise returns that come with the resolution cannot reproduce. 2. The tester's environment and the developer's environments are different. Again, it's all about conditions. There are situations where some kind of underlying item is different in the dev environment, for example, billy.sharelane.com, than in the test environment, for example, main.sharelane.com. For example, the dev environment could have a more recent version of the Python interpreter, so Billy could use the Python libraries that exist in his environment, but are missing on main.sharelane.com. The tester sees a bug and files it only to get a cannot reproduce resolution, which leads to a waste of time going back and forth with Billy, trying to understand what's really going on. 3. There is no bug. Here's a potential situation. The DB on main.sharelane.com is down for maintenance and the tester doesn't know about it. He sees the bug, tries to reproduce it with success, and then files it. The programmer tries to reproduce the bug when the DB outage is over, but the bug doesn't exist anymore. So the programmer sends the bug back with the cannot reproduce resolution. By the way, a similar unpleasant situation might happen when the testing is done while a push of a new build is underway. Always check the build status page before starting testing. In case of a cannot reproduce resolution, whoever selects that resolution should also assign the bug back to the person who filed it. It's the person from the submitted by field. What happens if a tester receives a bug back? He should either close it or provide more details and assign it back to the developer with an assigned resolution. See Bug Vault bug number 9. Pay attention to change history. Resolution. Duplicate. This resolution is selected if another bug was already filed for the same issue. In software companies, the BTS may contain thousands of open and closed bugs, and sometimes it's not physically possible to review each of them to avoid filing a duplicate. The best way to avoid duplicates is to do comprehensive search in BTS before filing a bug, and keep close look at all new bugs filed for the functional area or component you are responsible for. Example of the functional area is checkout. By the way, a professional BTS usually allows you to modify the settings for your BTS account and sends you an email if any new bug is filed or a filed bug meets certain criteria. For example, when value of BTS attribute component equals checkout. That way you'll know what was already filed. On the other hand, there can be not so obvious situations. For example, 2 or more filed bugs can be the result of the same root cause. Example? Let's look at bug number 4 in the bug vault, shoppingcart.py, 2% discount if user buys 12 to 19 books inclusively. The wrong way to do it is to file 8 bugs. 1. Shoppingcart.py, 2% discount if user buys 12 books. 2. Shoppingcart.py, 2% discount if user buys 13 books. 3. Shoppingcart.py, 2% discount if user buys 14 books. 8. Shoppingcart.py, 2% discount if user buys 19 books. The root cause is the following statement in shoppingcart.py. If Q more or equals 12 and Q less or equals 49, discount equals 2. So 1 bug is enough to cover all 8 cases. Black box testers don't look into the code, and situations like this do take place. So when the developer returns your bug with a duplicate resolution, explaining in comments that your bug was caused by the same code as another bug, don't take it personally. That happens and it's okay. Once a bug is marked as duplicate, the person making that change must also put the original, previously found bug ID in comments and assign the bug back to the person who submitted it. See Bug Vault, bug number 10. Pay attention to change history. Resolution, not a bug. Startups, especially in the early stages, are usually a mess. In some cases, it's really hard to find out the correct expected result, and our old friends, common sense and life experience, might be different from what the PM tried to communicate during his talk with the developer some time ago. In some cases, the PM communicates a product change to the developer and forgets to update the spec, mention that product change to the tester. In some cases, the tester is correct that it's a bug, but the developer thinks that it's a feature and sends the bug back to the tester. So be prepared to answer the question, why is that a bug? If you were wrong about it, but you had reasons for believing that it was a bug, then there is no problem. If you are not sure, and it's a good time to ask, hey, Linda, is this a bug or not? Then ask. If nobody is available, then file a bug report. It's better to file a bug if you have reason to believe that it is a bug and later find out that it's not a bug than be scared of the not a bug resolution and ignore the problem. In any case, when you receive your bug back with the not a bug resolution, read the comments section and try to understand what the developer tried to communicate. If you still think that you are right, go talk to the developer, and then if you both agree that it is a bug, send it back to the developer assigned to developer's alias resolution assigned with your explanations in comments. If you both agree that it's not a bug, just close it. Sometimes when a spec is poorly written, the tester and developer cannot come to a consensus about what the PM meant in the first place. In that case, reassign the bug to the PM and let him decide whether it's a bug or not. In a situation like this, we also recommend filing a separate bug against the spec. See an example of ping pong with not a bug here. See Bug Vault, bug number 11. Pay attention to change history. Resolution, third-party bug. The code in the software company cannot rely exclusively on in-house software, which is a software code written by company programmers. We use databases, compilers, interpreters, and web servers that have been designed and developed by others. In many cases, we also integrate our software with the software of our partners, for example, with credit card processors. So here is the situation. You file a bug. The bug programmer returns this bug to you with a third-party bug resolution and the comment that the bug is not in the software that he wrote, but instead in the software written by others. Here, we might encounter two situations. One, we cannot influence others to fix their software. For example, if the bug is in the Python interpreter, we cannot call Python's father, Guido van Rossum, and ask him to fix the bug before our release goes out. So the only way to fix the bug is to find some programming workaround. So, if a programmer returns your bug with a third-party bug resolution, it doesn't solve the problem because whether he likes it or not, help is not coming and we have to find a solution ourselves. In a case like this, talk to the programmer and reassign the bug back to him. See Bug Vault, bug number 12. Pay attention to change history. Please note that this bug was invented to illustrate the point. ShareLane application doesn't have this bug. 2. We can influence others to fix their software. For example, in checkout.py, we have the function getCCPResult. You can see source code here. Test portal, application, source code, checkout.py. This function connects to the payment processor to process credit card payments. Of course, in the case of ShareLane, there is no real processor, it's all training software. That payment processor software belongs to another company, which is our service provider, also called vendor. If there is a bug in the vendor software, then we can call them and ask them to fix the problem ASAP. As a rule, the tester usually doesn't make this contact. As a rule, a contact like this is the responsibility of the project manager, PJM. By the way, in startups, PMs are often also PJMs. So, if a developer returns a bug to you with a third-party bug resolution, in this case, you should reassign the bug to the PM, and that person would be the bug owner that is responsible for resolving the situation. See Bug Vault, bug number 13. Pay attention to change history. Resolution no longer applicable. This is usually selected for bugs found in features that have been deprecated. Deprecated feature is a feature that is still available to users but no longer officially supported. See Bug Vault, bug number 14. Pay attention to change history. Lesson recap. Bug resolutions include 1. Reported a bug was filed, but the developer to fix it has not been assigned. 2. Assigned. Assigned developer must start bug investigation. 3. Fix in progress. The developer is fixing the bug. 4. Fixed. The bug was fixed, but the bug fix hasn't been verified yet. 5. Fix is verified. The bug fix has been verified. 6. Verification failed. The bug fix verification failed. In other words, bug is reproducible after the bug fix. 7. Cannot reproduce. The developer cannot reproduce the bug. 8. Duplicate. The bug is a duplicate of another bug. 9. Not a bug. The bug is not considered to represent a problem, which is a deviation of actual from expected. 10. Third-party bug. The bug is in third-party software. 11. No longer applicable. The bug doesn't have any meaning anymore.